Hi, and welcome to this session on mWater maps, how to build them and how to make use of them. This is going to be 1 hour with me, Petri, the product manager for mWater and Solstice. And welcome everyone. We are recording this session for later use as well. Today we will cover a set of examples of how people are already using maps in mWater. And we will look at how to establish basic map layers, meaning how to map your site infrastructure information and also how to map your survey information, any data that you collect. We'll dive deeper and look at some of the more advanced features, such as mapping choropleth or administrative boundary data in mWater. And we will look as well at grid maps, so custom-sized grids, how to visualize your data with those, as well as population density layers and some other more nuanced things, with some space for questions and answers at the end as well. So let's get going. I want to show you some examples around mapping infrastructure sites, survey data, these choropleths, grid maps, population density layers, and some more. And let's go. Here's a very simple but broad map of global water points. So this is all the public water point information, which is recorded as sites in mWater. If you're not familiar with sites or mWater very much yet, sites are our basic way of crowdsourcing information about infrastructure, crowdsourcing it and making it easy for your organization or government to track over time. So there's a bunch of resources on why mWater exists available on our channel and on our website. Sites are the primary way to track infrastructure locations such as water points in mWater, and then also be able to track information over time that relates to those pieces of infrastructure. So you can see this public map, you can go take a look at this one, and this sort of shows how much data mWater can handle on the server side, so there's no limit really to the scale of data collection that you could do. Just map as much as you like. For the next example, I'm showing you some survey information here in Guinea-Bissau. So community-led total sanitation in this instance. So this is not primarily driven by sites, but instead by surveys. So this means that any custom survey that you create in mWater, you can also start mapping, as long as there's a location information that you track as well. So any information that you collect, you can also map, and we'll learn how to do that. Now, these are all point maps, point information specified on one location only. For my next example, just reload this tab, shows a basic example of choropleths, regions. If you want to see higher level insight, you can do these kinds of regions in our maps, and this is all driven by data within the system. So this example map is just highlighting some of the active project work that mWater is undertaking with UNICEF and LIXIL in East Africa. But the point here is that these kind of regional and district and so on layers can be created by you, and you can drive how they get colored on the basis of the data in your surveys and in your sites. So it's not just about point data on our maps. Similarly, what we'll look at today is building grid maps. So I just showed you how you can use these pre-existing boundaries that mWater provides for all the countries available, and those are sourced from official sources. But sometimes you might need more granular information displayed in a regular tessellated tile-based way. So we provide both these hexagonal 6-sided tile maps and square tile maps that you can customize and will be able to build. In this example, we're looking at the average depth of Malawi boreholes on the basis of water point data. So whether or not an individual tile is colored darker green or red, it's entirely determined by the live data in the system. So the system is calculating the color on the basis of all of these points on the map for each of these tiles. So you're not limited to building maps around average depth. Anything basically that you can get into some kind of categorization, any data you can turn and visualize on a map with a grid as well. So certainly not limited to just points. This next example shows automatic population density information. This is a kind of neat feature that you may use as an overlay with other information. We have separate materials on what this is, but in brief, this is information derived through machine learning from satellite imagery about households in the world, and then these dots represent the density of estimated human population and household population in any given area. Now you could imagine this being useful in planning your work and just checking whether to prioritize a certain construction or rehabilitation or support process depending on where there's dense population or whether there are gaps in service and so on. So this is automatically provided and periodically updated on the basis of satellite information. And we will look at how you can add this kind of layer to your map as well. And then, as I've been saying, there's a bunch of layer options available. Here is an example from Haiti, and you can just keep adding layers to your map and turn them on and off by just a click of a button. So if I don't want to see the commune boundaries, I can deactivate it and the server will calculate for me the remaining layers here. So the planned interventions and so on. So a lot of data, even up to the level of managing wash data for a whole country, is possible for free for you in mWater. So that's just a flavor of the kinds of things that people are already doing in the system. What you can get to with a few hours of practice and having data in the system. Let's look a bit more at how exactly these get built. These examples. So the basic idea is that you can visualize and share any data you have in mWater, any data you have access to, as long as that data somehow has GPS information attached. So there is a point location attached to it. This applies even for the regional maps and the choropleths and the tile maps. But that can mean survey data. So a survey that you create in mWater in the portal. You can add any questions you like, text questions, number questions, photos, and so on. But you have to have a location question or a site question to be able to get that data nicely on a map in our system. So if you want to map your survey data, make sure you have a site question or a location question. The site question will then link to an infrastructure site that you discover or create, and that site will itself have location data that can then be mapped. You can also just pick out sites. So if you're mapping water points only, or schools, or health facilities, or communities, you can pick out the location from there. Finally, there's a broader array of data that some users make use of in mWater. That includes our issues or tickets, tracking if a water point breaks down, for example. Automatic sensor information is possible, and even custom data tables. But the common element is that you need to have this location information somehow accessible, and then you can pick out anything related to it from the same survey, etc., that you then map. And the basic steps, are very straightforward. The idea first is to select your data source, whether that is a survey, site, issue, custom table. Step 2 is to select the location field that will inform the map of the GPS information, so the precise location of the data. And that can be, if you're talking about a WaterPoint site, that can be the site location, or it can be the survey location question. And once you've done that, you're going to start seeing stuff on your map, on your basic map. And then we can customize. So we can choose the color, how we visualize it, what data field are we visualizing, and how, and a number of other options we'll see live. But you do need to know your data source, you do need to have the location field, and optionally you might need to have selected a data field to drive the visualization. Now, mWater is not a fully fledged GIS software and not aiming to be QGIS and so on, so we have key mapping features that are free and you can use to quickly and efficiently map your data, but you can also export your data out. Let's move on to create a basic example map and then build on this example. So let's say I want to start a new map, altogether fresh. I'm at mWater portal, or I'm on solstice.world. Solstice is our sister brand that goes beyond wash. mWater is our wash-focused platform. What I'm going to show you will work for both. I will click Maps, and I will, on the top left, click Make a Map, start a new map. This way I will get a full page map. What I'm showing you is also useful if you're building a dashboard, and in a dashboard if you are creating a map widget. The same rules will apply. I'm going to save my map, and in today's examples I'm going to build a number of map layers for Malawi. But before we get to that, let me just give you a sense of the interface for building maps overall. So, here on the right side, we have the builder of layers. So, the layers are the different sets of data that you want to bring to your map. It can be one, it can be many, but you have to have at least one to show data. And you can map sites, you can map surveys, or you can do something even more advanced. And we'll cover all of these. If you want to apply overall filters, you can do that here. We'll come back to it when we've set a layer. And for options, you can set options that cover the entire map. So you can choose between a number of backgrounds: light, dark, road map, satellite map, or just blank. Blank maps will become useful when you are using choropleths map layers. You can adjust the opacity, the transparency of the layer, and you can set an automatic zoom, which means the system will try and zoom in on any of the data that you have mapped. You can add an attribution, means a text at the bottom. That will show up here if you want to get some extra information. At the top bar, let's cover our options. We can print our map even in high resolution, so you can build a fancy map for a whole country and then print it in high definition. Gallery will take us back to the map view. Share is really important. It is where you can manage your permissions for the map. So who can administer the map, meaning they can change the map, they can even remove the map. There should be only a very small group of users or one user who do this. View means who can view this map in mWater and share the link of it. So if you want to have your colleagues viewing this map, be sure to add them as viewers. If you want to share the map with stakeholders outside of mWater or Solstice, you can create a map link, a share link by pressing this button, and then the user can view this document without logging in. So you can share either within or without mWater. So share. Duplicate is a nice button. It copies the map design, and you can use this for any map that you have view access to. So one good way to learn maps, I find, is to find a nice one, then duplicate it and start editing it and taking it apart. You can do that by duplicating maps. Undo and redo. And finally, this lock icon. I'll just mention it here. This means this allows you to set how the map will show up to your users, in which location. So if I'm the administrator and I want the map to always zoom to Malawi, I open the lock and now I lock it again. And now if I refresh the page, it will start here. If I unlock it and move it and lock it again, this is where the page will open up. This is because if I'm an admin and I'm just exploring, investigating my own data here, and then I leave, we don't want the user to open up and end up in this corner only. What we want to do is show all of Malawi, and we can do it by unlocking and then locking. Great. So that's the overall interface. Let's build a layer. I want to see all the water points in Malawi. How do I do that? I create a layer. I want to create a site. There are water points. So I select water point. I'm going to select all the ones visible to me. And that's already going to create the global map. I only want to see Malawi though, so I will customize the layer. I can do this in two ways. I can apply a filter and say this is only for Malawi. It's pretty nice. In the filter, so it is filtering out everything that doesn't belong in Malawi. The other way to do it is to start customizing and add a filter. But before we get to the filter, let's see what we have. We already got the water point data source selected, and the system was smart enough to pick the location of it. So how does the system know that there's a water point here? It is because this site that I clicked into has a location information. And it was smart enough to do that. I could change this. Let's revisit it. I'm now in the water point data structure. I pick the GPS location. That informs my map how to place the points. What can I adjust as well? Marker color. I like it a bit lighter blue. Here we are. I can also adjust the symbol of it and the size of the symbol. Maybe because there are so many mapped for Malawi, over 100,000, dot circles are better. And the server will redraw the map for us in the meantime. So you can adjust the visuals and make the map more useful for your needs simply by adjusting it there. I'm zooming in and I can see that all the water points that are visible are mapped in such a simple way. Now, as I showed, these are all driven by data. I can click into them. So there's data underneath and I can view the site just by clicking the map. But maybe this could be more informative. Just to show you how, I will color this by data. So I will click select color by data, and now again I'm seeing all of the data that is accessible to me in the site. I'm going to slow down here because this is an important part of using mWater, is understanding the data explorer. There's a lot going on here, and the key concept is I'm looking at the water point site data definition. So these are all the things I could possibly pick when I'm using water points as a source. There's quite a lot. Indicators, surveys, and so on. Maybe I want to map the water points by type. So I've selected color by data, and I'm giving it the answer by type. So now instead of just coloring everything in a single blue color, it is going to use the data from the site data field type to make a determination of the color. So here we see some trends, for example. Looks like there's a lot of boreholes here in this area, whereas there's a lot of protected dug wells by this color in this area. So I'm getting more, an extra dimension of data on my map. How did I do that? Instead of just having plain data, I chose color by data. I decide on the field I want to use, and I choose data. I choose a type as my data. And if I want, I can change the color scheme from ready-made ones, or I can individually adjust them by clicking the color here. If I'm not interested in, let's say, protected dug wells at all, I can hide them from this checkbox. Piped water, and so on. Or conversely, if I just want to see piped water, I can untick all of the other ones and only leave the pipe data visible. So this gives us a better view of where there's piped data in Malawi on the basis of the data we have in mWater. So this is already a really key thing in your basic mapping vocabulary for mWater. If you know this very well, that's your main takeaway from this video, I would say. Create a layer, choose a data source that has a location in it, and then you can start coloring by data. But we'll build a few more examples. I could filter this down further by any dimension of my data. So I could say by type I'm only interested in pipe data, or by location I'm only interested in Malawi. So let's say here I want to narrow this further. I want to narrow my data by district. And I want to say the district is only Blantyre, perhaps. It's loading through the options, but these filters become very powerful in narrowing down what you're actually wanting to demonstrate with your map. I choose the district. Now instead of showing all of Malawi, I should just see whatever is visible in Blantyre. Great. So you can use filters. Customize pop-up. We might get back to this later, but not just now. What this means is when we click into a point on the map, we get this pop-up. And this is just the default pop-up. That's always the same. And now if you want to customize that, so instead of showing the title and the ID and the map and so on, you want it to show some other stuff that's more relevant to your survey or something else, you could do that by creating a customized pop-up for this layer. Advanced options, you can set the zoom levels. So now I can zoom freely, go out and go in. Maybe you want to constrain that. You put some numbers in there, 4 and 20, for example. And then it won't show, oh, it will show. Given those. Now it's no longer showing. So, opacity is adjusting the transparency of the layer. If I just want to have them show up really faintly because they're background information, we can do that. And the hide legend toggle hides or shows the legend. This can be useful if you have a very, very big legend or you have lots of layers and you only want to show some of the legends. So this was our first layer. Let's add another one. Let's look at the schools in Malawi as well. So kind of the same flow. It's a site, it's a school. So remember, sites are infrastructure points like schools, communities, health facilities, water points, and so on. School. Let's start again. Now I selected all, but because I filtered it down to Malawi, only Malawi shows. I want to customize it some more. Let's make them black, and let's make them institutions, like so. A lot of schools have also been mapped. Okay, so now I'm getting a bit of an overlay. And I could go deeper. Let's say I want to see whether they're primary schools or secondary schools. I can color by data again. So I've got the schools, the location is driven by the site information, and I am going to choose type again, because the type is primary, secondary, or university. Let's change colors for... Oh, that's not good. That's more visible. So now I can see primary schools, secondary schools, universities quite neatly. Primary colors might be best. Okay. Any adjustments you make, they'll be made live. And you can see that both of these layers are there on top of each other. So you can layer up your data. Let's see if we can find a nice example. Because I created this school layer second, it is the one that gets drawn on top. So here you will see that there's a water point behind the school. If I want to change it around, I can drag and drop. So now the water points are drawn last. We'll show this again. So we've created two site layers. Starting to get quite a bunch of information already. Let's add something more. So I want to add survey data. This was all publicly visible site data. That's nice. Let me deactivate those layers and jump to something from my own data. I have completed a data collection in Malawi. I've created my water point survey, and I'm now creating a map on the basis of that. So my water point survey, it has two location questions. I'm going to choose this one. This links to my site. And then this little wizard here allows you to choose what answer you want to visualize. You can change this later, but let's say I want to choose the functional status and create the layer. This has a few sets of data, and now instead of this public information, I'm getting only my survey data visualized here. So, what do we have? We have a new layer, my water point survey it's called, and what do we see here? So we chose the data source. We chose it when we were creating the layer. Now this can be your own survey. And because this data source contains links to sites, the system asks me, do I want to show all the survey responses or just the latest response? Well, I happen to know these are visits that I'm doing periodically to these sites, so I'm showing the latest. I want the newest data. And the marker position means where does the system draw the dot? That needs the GPS information. So it has chosen the site link question. Let me recreate that. If I take this away, nothing will show up. So if you're confused when your map is not showing anything, number one thing to look at is, does it know which location to map? Now, where do I find it? I'm back to my data exploration window, but it looks different from before. Why? Because now I'm looking at my survey instead of the site. So my survey only has a number of questions. So I'm navigating to main section, which water point, and location. Here I find the location question. I could also look for it perhaps there. So main section, location here. And this is totally dependent on how I've structured my survey. To drive that point home, if we look at the survey itself, this was the question. So this is exactly what I'm saying. There's a site question. I'm going to see that. So now I've got this layer, and it's coloring by functional status. Now, the coloring is not great. I will adjust it. Green if it's working, orange if it's partially functional, red if it's not functional, and so on. Okay, so I'm seeing information from my survey on a map so easily. And otherwise, the the same. This filter is showing up because of this selection here, so it just helps you out a bit. If I wanted to color in another dimension, I can change the color by data. So I delete it, and let's say I want to see the project phase, baseline, midline, endline. And that's a drop-down single select question. And we can see that the latest ones, remember it's showing the latest response, so I can see that for these water points we have reached the monitoring phase. But for here, for some reason, we're still stuck on the baseline, or it started later or something. So what I want to demonstrate is that any data you have in the system, in your survey, you can just pick. You just need to know where to go. And you can do that. Here it's coloring the points on the basis of whether there's a response to this question. Not many of them seem to have that. Let's say water point functionality from here. Back to that. Nice. And one more time, change the color by data. Choose the location type. Is it urban or rural? So, as you can see, anything I've got in my survey here, I can pick out and bring to my map as well. So we've looked at site layers and survey layers. Let's take this to the next level. Let's build a color region map. Unless there are questions at this point. No, I think everybody's with me still. So next layer. I'm doing an analysis for all of Malawi, but I would love to see a regional split. How do I do that? I go to Advanced, and what do I see? I know I want to take color regions. Markers just means I want to have points on the map that aren't by sites or by surveys directly, they're driven by anything else. Circles means if I want to have a radius around my points, let's say a kilometer around my water point, and color regions is what we're after. So let's start creating one. Okay, immediately I get the regions of the world mapped. I get these white layers for the whole world. That's nice, but I want some more detail. So I don't just want a approximation of Malawi, I want to make use of mWater's admin boundaries. So I start to customize my layer. Give it a name, I type there, and I want to choose Malawi. So region to map, Malawi. Then it gives me the detail levels, and these are dependent on what we have within mWater. If you use this functionality and you think that it's out of date or there's a gap, please get in touch with us so that we can support you in updating it. We will then update that. If you want to update in a specific way, we need to get that data somehow from an official government source. So it automatically gives districts. That's nice. I've now created my color region map, narrowed it to Malawi, and I get the Malawi districts. But I'm doing a more detailed analysis, so I can zoom in even further to the TA level. Either way. I can choose not to show, or to show the region names, and I can fill them somehow. So I could just have a basic fill, just for visual purposes. This is not data driven, this is just color. Pretty straightforward controls here, but can be very nice to delineate stuff. If I'm drawing these points. Now notice that I created this last, so it's actually these layers are drawn on top of my points, so it can make it look a bit muddled. I will drag and drop my area to the top. That means it's drawn first, which means all the other stuff is drawn on after it on the screen. So now all my points look clear. Well, that's nice, but why don't I do something with these areas? I don't have to just have them as this background. What I can do in mWater is to use a data from my sets, from the surveys and sites I have, to color whole regions or districts at once and do higher level analysis and insight and demonstration of my data. So let's think about what we might want to show. One example would be borehole depth for Malawi, or another one even simpler is the proportion of piped access. So let's see, I want to kind of investigate where do people tend to use pipe or have access to piped water. How do I go about doing that? Well, I need to change the mode of my color region map. Instead of a single color, green, I will color it by data. So now we need to go through the steps we've seen before, which is, okay, the system now knows that I want to color this map by data. What data is it? I want to do it by water point type. So therefore, I select the data source as water point. And just to be clear, how the system is going to make this calculation is going to look at all those hundreds and thousands of points and see whether they fall into the area or not. So I've chosen water point as the data source. The location this time is picked as the administrative region. So this has calculated what I just said already, and it automatically does that. So that's a nice element of having a site. Now great, it's Malawi, it's district, it remembers all that, lovely, but it doesn't actually give me color because I have not entered the color by data formula yet. Let's do that. Clicking color by data now. And what I want to see is how much, what proportion of the water points are piped. So I choose type, and it gives me this formula. Percent where type is any of something out of all of the possible options. So we're already getting a bit more advanced, and this depends on the data you select. So again, you could imagine customizing this to your use case. Whatever your data is, explore this. But I click select, and I get these options. So what I'm seeing is all the possible things that a water point type can be. If I choose the piped options, it means what this formula is telling me is calculate the percent where the type data field is one of these three piped options out of all of the options. And I can choose the range, 50, maybe that's not granular enough. So you can see that creates 5 buckets, 5 categories. I want to see more detail, I say 100. And let's say 10 bins. Okay, and then I'm already getting the data. So I'm getting this data specifically on the basis of the data in the system. I will change the color scheme by going from red to blue, let's say, so I can sort of see the proportions a bit clearer. But maybe this is too much. I've reduced it to 5 bins now. And change the color scheme again. Okay, so I can see these areas where we have somewhat piped connections, medium amount, and fairly high proportion. And now we can, let's make this even more detailed. TA level, starting to see trends. So all of this is driven by the water point information underneath. Let me remove this filter from this layer so it's no longer looking at Blantyre but everywhere. And we can see where this is coming from. So these red dots are all piped systems. So piped connections here in this traditional authority are making this blue because there are so many. Whereas we can see that in this national park, for example, there don't seem to be any mapped piped systems. That makes sense. So we're getting this amazing comparison and higher level insight. We don't just have to trust our eye's ability to look at thousands of points, but we can set up these rules. So just to recap, we selected color regions from advanced. Ultimately, we selected color by data as the mode, the right data source, picking the administrative region, meaning these ones. We chose the region to map and the detail level. And then we created the formula to actually give us a result. And this can be applied to a lot of data. As we saw in our examples we saw earlier, this is for entire countries, showing where there's activity, for example. There's no strict limit to that. Let me just change the color scheme one more time. Great. So this is making use of the admin boundaries we already have. But let's go deeper still. Let's make our custom grid. So we covered color regions there briefly, and there is a specific video on these and documentation on how to make them. Cluster means just showing a number. Let me quickly demonstrate that. Let's say I want to show water point clusters. It will just show that there are thousands here. It's just a way of aggregating information and kind of giving a high-level summary at a glance. Let it calculate for a bit. Oh, stuck calculating there for a moment. I'm going to give it the cluster name. But that was simple, 2,599 in this part of Malawi, and so on. And it doesn't do anything more fancy than that, but can be useful. Grid, however, is more advanced. Grid allows us to create the equivalent of these admin areas we just saw, but instead we will get a regularly shaped grid. Regular shaped grid. So here we will do grid map, and let's go for the same thing. Let's say we want to investigate our piped access, but in a more regular shape. So mWater allows you to map as 6-sided hexagons or as squares, and we'll look at these first soon. But now let's map it. So the same process: data source water point, location is the GPS, color by data, we choose the same logic. We want to color by the percent of sites being piped. Wow, okay, so we get a grid. What else can we do? Let's add some borders to our grid. So now we get this regular grid, doesn't count geography, just a regular grid. Is this informative? Can we make it more informative? We can. We could choose to make it hexagonal. It's a bit prettier, a bit more equidistant in 6 directions. What happens when we zoom in? That depends on what you've selected here. So now we see that, what does this mean? This means that within this area of 30 pixels on your screen, there is a proportion of 80 to 100% of all the water points in there are piped. And in this area, it's a lesser amount, 40 to 60. So if I zoom in, because I've selected pixels, I see more and more detail. So each zoom level, I'm only seeing the area remains at 30 pixels across my screen. So what that means is the more I zoom in, the more specific and granular my grid layer is. And I'm hiding the gray ones. So for these gray ones, there's just no data. So let's overlay water points with that. Moving the grid layer again. I can see there's no water points here, and so on. Let's make this even more informative by unhiding all the other ones. So jumping around a bit, what I'm doing is making all the water points visible. So quite a messy data otherwise, but the grid can make our analysis much cleaner. So here we see there are just no piped connections. We just see more. Now I'm realizing that the background here is not that visible. So I'm making these adjustments here. Nice. Find a nice visual balance for my map. And I can adjust it to a different size. 50 pixels, so 50 little dots on my screen. That's bigger, even bigger. Okay, so these are totally customizable. That's the strength. They're regular and they're customizable grids. If I were to change this from pixels to meters, it means that no matter the size of the map, it's always doing the analysis in 1,000 meters in the world. So if I zoom out, the map grid will show smaller and smaller up to this level. (2,000 meters). So each hexagon is 2 kilometers wide. If I change to square, each square is 2 kilometers wide in this example. Hopefully this is clear enough. Grid maps, we could use it for borehole depth. Let's try that. Or for functionality. Let's try that for functionality. So, add another one. I'm going to create another grid map looking at whether the water points in an area are functional or not. Advanced, grid, water point as my data source, location, GPS, color by data, functionality. Where do I see that? I know that it's an indicator, functionality indicator. So I can find it here, or I can use my search. So if you've devised your own survey, please use the search function to find what you want. I click water point functional status, and it gets added as a related indicator. Now I can open the indicator, and I see there's a whole bunch of stuff inside there. I'm interested in the functional status because I know that's the functional or not thing. So I get another formula. Percent where water point functional status is any of functional. So now I see, regardless of the type, are water points functional or not? Now here it might make even more sense to have a red to blue spectrum. And let's make these a bit bigger as units of analysis. Name this water point functionality grid map, grid layer. So this is telling us at a higher level, perhaps where we might want to intervene or invest more. So in this area, water points are working at a very high rate, so 80 to 100% have been marked as functional on the last visit. And here, only a small fraction have been working. So big disparity there. I want to know more. I can zoom in. Aha, here we go. So it recalculates this on the basis of the pixel size I've set. So is this data accurate, I can ask? Is there much data going on? So now, also to mention, even one data point will color the whole area, right? So it's good to understand, is there much data? Is there little data? What's the situation? These are gray, there's no points. This area has been turned blue just by the presence of one single point that's working. So is the data representative? What's the coverage level of it? Here's a lot of, I think, piped systems that are working and so on. So, okay, you'll start to get the idea of how useful grid layers can be and how useful areas can be on the basis of this hour. The next thing I wanted to show you is our population density layer. And there's a separate guidance on this and all of these. This is just 1 hour bringing it all together into one map. Population density, what does it mean? So this allows you to bring this automatically created layer of population density information. I only need to type the country I'm interested in, and it will create this visual layer. Now note that to see these dots, because there are hundreds of thousands of them, you have to zoom in close enough. So they don't show, they don't show, now they start to show. And what does it mean? These are fundamentally pieces of data derived from satellite images automatically using machine learning, and they make a determination by scanning the images for basically roofs of houses to show how densely populated can we estimate the area to be. Is there any population? No. Is there low population? Okay, here. Or quite dense, like bigger buildings with more families living in them, perhaps. And this is, machine estimated, might not be perfect, but it is regularly updated. And you can add this as a layer to, see if there are gaps in coverage and maybe prioritize your work depending on your use case. It looks pretty neat. So let's overlay some water points here. Make them large. So are we spotting gaps, for example? We don't see any water points here, but we do see some dense population and so on. But we do see a coverage and overlay reasonably well of population centers. Population centers here and households there. So it's an approximation, but it is, as you saw, very quick to do. So just one more time. How do we add a population density map? Add population density, type the country you're interested in, and we have a whole bunch. So it could be Egypt, could be Indonesia, automatic there. So we've covered a whole bunch of different types of maps you can build, as kind of heavy or light as you like. Let's see if there's anything more. The last thing here, the two things are tile URLs. So that means if you have somewhere else on a server, if you're more of a GIS mapping person, a visual layer, you can then bring it over as a drawing on top of our mWater map. What do I mean? Let's take a look at a concrete example here in Haiti. It's this one. It means groundwater potential is one of these layers. So somewhere on the internet there is a drawing, a raster layer on tiles.arcgis.com. So you need to know how to set this up, but if you have that set up, you can paste that URL and then it will draw that layer on top of our map here. So you can see groundwater potential, and you could do that for a number of other use cases. Finally, there is the WaterPoint Mapper Wizard, sponsored by WaterAid, where you can, by guided steps, create a number of key water-related maps. So what do we have? Things such as functional water access, safe, improved access, percentage to all members, and things like that. Reliability, fee collection, and so on. So we can go through the wizard in each case. And get a finished layer at the top, at the end of it. which seems to show that not many layers, not many points actually have this information for Malawi. But that's okay. Let's try one more time. Water point mapper wizard. Functionality this time. Functionality status for Malawi. All organizations, that's reasonable colors, finish it. So even faster. Well, here we have much more data. So just with a few clicks, we got the functionality status on the latest visit visualized. So use the water point mapper specifically for your water point information. Okay, so anything else to cover in our 1 hour? There's a bunch of resources. I realize we went through these things reasonably quickly. Look at our resource center, please. Follow our YouTube channel to find more videos specifically on individual map features and other visualizations, as well as other parts of mWater. You can always take a look at the existing maps on the platform with your free login. And as I mentioned earlier, a nice way to learn might be to duplicate an existing map and take it apart and change it around and build on that. Also take a look at solstice.world for any use cases you might have beyond WASH, water and health, because the functionality is just the same. So anything you might have learned here today is something you can use in Solstice as well. And you can follow us on Facebook, on Twitter, on LinkedIn, as well as the YouTube channel to stay up to date on our new features. We keep developing new map stuff, so we will have more and more on utilities, for example, with our maps. So it's not a static thing. And we will also this year have, in 2020, we will have a feature to allow you to import your own shapefiles and your own administrative boundaries. So if you have, for example, catchment regions of water, you might want to have that mapped as well. So keep up to date on our latest updates, and please feel free to get in touch with info@mwater.co or problems@mwater.co, or directly to me at petri@mwater.co. That is petri@mwater.co, to help us get in touch if you need us to help you with resolving any issues with your maps, any bugs, or if you perhaps want training or further discussion on how maps work in mWater. And that's it for today's session. So happy mapping, everybody. Thanks for joining me today.